In this video, we're going to calculate how to find area between curves. And in this first example, I have f of x is equal to negative x cubed minus x, g of x is equal to 0, x is equal to negative 1, and x is equal to 1. So I have a rough sketch of negative x cubed minus x on the screen already, and then we need to draw the other curves in. And remember, g of x is equal to 0 is just the x-axis, so it's already drawn in for us. And then we have x is equal to negative 1, which is a vertical line. And then we have x is equal to 1, which is also a vertical line. So now we need to look for areas that are enclosed by all of these functions. So here in this area, we have to find the area in here, and you can see that it's enclosed by our y is equal to negative x cubed minus x is equal to negative 1, and x is equal to 0. So this is fully enclosed. And then we have this area here also fully enclosed. We have the top being 0, the right side is x is equal to 1, and then the bottom function is our f of x is equal to negative x cubed minus x. So now we need to find the area of each of these. Now whenever you have multiple areas, we need to do them individually. So we'll call this area 1 and we'll call this area 2. And now we need to find the areas. So we'll say area 1 is equal to, and remember it's top function minus bottom function when you're finding area. So we have the top function here being negative x cubed minus x, and the bottom function is g of x is equal to 0. So minus 0 dx. And now our limits of integration are going to be from negative 1 to 0. And we got that by looking at the numbers on the x side and saying, where does this area go from? And we go from this point at negative 1 to 0. So that's how I got that number. And then the setup for area 2 is going to be area 2 is equal to, now the top function is 0. And we need to make sure we remember that. So from 0 minus, and the bottom function is negative x cubed minus x. And our limits of integration will be from 0 to 1. And now we need to solve both of these integrals. So area 1, we have the integral of negative x cubed minus x. So we have negative x to the fourth over 4 minus x squared over 2 evaluated from negative 1 to 0. And now if we put 0 into both functions, we end up with 0 minus 0. So that's the top, minus, when we put the bottom number in, negative 1, we get negative 1 to the fourth, which is 1, and then divided by 4, and a negative out front. So we end up with negative 1/4. And when we put negative 1 and we square it, it's positive 1, so minus 1/2. So area 1 is equal to negative 1/4 minus 1/2 is negative 3/4, and then we have a minus sign out front. So it's equal to 3/4 units squared. And now for area 2, we're going to do the same thing. Now I'm going to rewrite this one and get rid of the negative signs. So here I have positive x cubed plus x because of the negative out front, dx, which is equal to x to the fourth divided by 4 plus x squared divided by 2, evaluated it from 0 to 1, and now we plug in 1 and 0. So when we plug 1 in, we get 1/4 plus 1/2 minus 0 plus 0. So we end up with 1/4 plus 1/2, or 3/4 units squared. And if we want the total area, A is equal to A1 plus A2. So our total area of this is 3/4 plus 3/4, which gives us 3 halves units squared. And it's units squared because it's area. And they didn't give us any specific units, so I just used the general units term. In the next example, I have two functions. F of x is equal to 1 minus x squared, and g of x is equal to x squared plus x. And I drew the two functions. Now it's important here, and the difference between the last problem and this problem is that the last problem we were given 4 different functions and it enclosed the area. For this problem, for our limits of integration, we actually need to set these two equal to each other. So 1 minus x squared is equal to x squared plus x. And now I'm going to move everything to the right, so I have 2x squared plus x minus 1 is equal to 0. And now I'm going to solve for x. So I have 2x and x. And we need a number that multiplies together to give us -1 and adds to give us +1. So I'm going to put a +1 here and a -1 here. And now we can see that x is equal to -1, and then 2x minus 1 is equal to 0, 2x is equal to 1, and x is equal to 1/2. So these points are actually already on the graph, and they're represented by these 2 points here. So we have 1/2 here, and this ends up being 1/2 3/4, and we won't need the y value, but I was just putting it up there. And then at -1 we're right at 0, and that's where these two intersect. So sometimes it's better to do this step before you graph the picture. So now we can see that we're looking for the area in between these two curves, which is this area. And again, we're going to be top function minus bottom function. So area is equal to the integral, and remember we're going from -1 to 1/2 of the top function, which is up here, and that's represented by 1 minus x squared. So we have 1 minus x squared minus the bottom function, which is x squared plus x dx. And now I'm going to take 1 second to simplify this before I integrate. So we have the integral from -1 to 1/2 of 1, and then we have minus x and minus 2x squared dx. And now we can use the power rule to integrate each of these pieces. So we have x minus x squared over 2 minus 2x cubed divided by 3, evaluated from -1 to 1/2. And now we'll do top minus bottom. So we're going to plug 1/2 in for all the x values. So we have 1/2 minus, now 1/2 squared is 1/4 divided by 2 gives me 1/8. And then we have 1/2 cubed, which is 1/8, times 2, which is 1/4, divided by 3 gives us 1/12. So minus 1/12, minus -1, then -1 squared is 1, so minus 1/2. And then we have -1 cubed, which is going to give us -1. So the two negatives make this term positive, and we have 2/3. In order to add these, I'm going to find a common denominator. And the least common denominator I see is 24. So I'm going to say this is 12 over 24 minus 3 over 24 minus 2 over 24. And now a minus and a minus gives me a plus 1, which I'm going to write as 24 over 24. And a minus and a minus again, so plus 12 over 24. And then minus a plus, so we have a minus, and we have a 24 on the bottom and 16 on the top. So now I can add all these numbers up. And when I add 12 minus 3 minus 2 plus 24 plus 12 minus 16, I end up with 27 over 24, which is also equal to 9 over 8 And again, I'm units squared. And that's how we find area between curves.